And now, ladies and gents, we are looking at question 10. They say to us, we've got the diagram below that is shown. It shows a photoelectric cell which is connected to an adjustable EMF. All right, and they say to us that a group of learners use this device to study the photoelectric effect. The learners irradiate the cell with blue light, right? It has a wavelength of 470 nanometers. They record the readings on the emitter as the cell is irradiated with blue light at different grades of intensity. Right, now they say to us, describe the photoelectric effect in words. Right, so please remember that definition, right? That is the emission of electrons using light energy. Okay, but of course that's not the formal definition. Please just look it up. Okay, now I'm going to go to 10.2. They say for us, for this experiment, write down the following: the independent variable. Right, so I want you to please note in this case, what did they vary? Right, they said different shades, right, of intensity. So they are changing the intensity. So I can say that the independent variable is the intensity of blue light. Okay, now they say to us one factor that must be kept constant with respect to light. Okay, so one thing that we have kept constant would be the frequency, or we can say the wavelength of the light. Okay, so we're making sure that we are using blue light throughout. And then in this case, so we are going to keep the frequency of the light, or in this case, the frequency. Nothing wrong if you said the wavelength of light, okay, of the blue light. Okay, right, now they say to us an investigative question. Remember, guys, we always need to find out, every time that we ask a question, right, it must be able to interrogate fully, right, the relationship between the independent variable and the dependent variable. Now, in this case, what are we trying to do? Right, we're trying to find out, right, the effect of the the different grades of intensity on the photoelectric effect, right? Okay, so because we are measuring, they record the readings on the emitter. So I can say, so how will the intensity of blue light, that's our independent variable, affect the photocurrent? Or you can just simply say the current on the emitter. Okay, and please remember to put a question mark, right? The photocurrent, in fact, let me just say the current in the circuit. Okay, just want to illustrate that every time you ask an investigative question, it must end with a question mark. You know, it might seem very obvious, but oftentimes you guys just miss that and as a result lose marks. Right, now the next question says, the learner observes that the emitter reading increases when the intensity of the blue light increases. Explain this observation. Right, so remember that an increase in intensity, okay, so if we increase intensity, we will also increase the number of electrons emitted per second. Okay, increases the number of electrons emitted per second. okay? And in this case, that will increase the photocurrent, okay? Right, now let's go on to the next one. They say the metal of the photoelectric cell has a work function, okay? That's the work function there. Calculate the maximum kinetic energy with which the photoelectrons are emitted. So I'm going to say, well, we know that E is equal to omega 0 plus EK max, okay? Right, so we want the photocurrent, or rather, we want to find out the kinetic energy, the maximum kinetic energy. But remember, we're given the wavelength of the light, right? So we're going to say this is HC over lambda. Remember, this would have been HF, but we know that F is equal to C over lambda, okay? So that's HC over lambda, the work function, plus EK max. And now because we're looking for EK max, we're just simply going to substitute there. Okay, so I'm going to say EK max would simply be, now remember that's Planck's constant, that's 6.63 times 10 to the minus, to the exponent minus 34 times 3 times 10 to the exponent 8 divided by the wavelength, and the wavelength is 470 nanometers, so that's 470. Nano is times 10 to the power minus 9, all right? And this is minus the work function, that's 2.35 times 10 to the power minus 19. Okay, right, and ladies and gents, let's reach the conclusion. So I'm going to say 6.63 times 10 exponent minus 34 multiplied by 3 exponent 8, and this is divided by 470 exponent minus 9. Right, and this is subtract 2.35 exponent minus 19. Right, so in this case, okay, I am going to say the final answer, EK max. All right, it does look like, let's see, did I do anything incorrect there? Okay, and we subtracted. Okay, so let's see. The answer that I get there is 1.23, right, times 10 to the power 3, and remember EK is in joules, so that is in joules. That's going to be the amount of EK max, but for some reason I don't believe this amount is true, but nonetheless, please just make sure that you help me out there, and let's see if you get to any. Yeah, so I said minus 34. Yeah, I do get that value. All right, you can let me know if perhaps there is something that went a little bit amiss there. So, and now the last question, they say, briefly explain why metals shine even when the frequency of the radiation falling on the surface is below the threshold frequency. Well, remember that the property of shining of a metal is because it's able to reflect light, right? So remember, in this case, when light is incident on a metal, right, it enters there and the metal is able to reflect that light. This is what we observe as a shine, okay? Right, you can explain that, okay, and talk about the reflective property of metals. All right, guys. we come to the end of this question paper. Really one of the best creme de la creme question papers. Okay, so I hope that you will be able to follow on in what we've been doing and that it has helped you. And please, if you have any struggles with maths and science, you're more than welcome to get in touch with us. And our details are on the description of this video. Right, as from me for now, I will see you guys again next time. Sharp, sharp.